time because, yeah, it's been a while. So I want you to be safe. So anywho, welcome. Happy Friday. Here we go. We, I've already told you, are going to go over lab safety and burner lighting. And then I'm also going to give you a quiz. It's not really a quiz. Don't panic. It just says quiz on it. It's not a quiz, but you do have to do it. And I'll try not to talk too much so you'll be able to get it done in class. I want to share this interesting statistic with you. Last year, the first 7 weeks of flu season had 174,000 confirmed cases, according to the Centers for Disease Control, CDC. And this year, that same 7-week period, we have 1,500. We'll just add the one more in there. So, yeah. So, do you think fighting a virus with masking, hand sanitizing, and distancing helps prevent the spread of disease? Yes, it does. So that is a huge, huge difference. And thank you, all of you, for continuing to be smart about taking care of each other. And it is the nice thing to do. All right. What are we doing? We are going to look at this document. It says Burner Basics. And it has, it's from a company where I buy chemicals from, Flynn Scientific, and they, it's a multi-page document. Unfortunately, it's a Word document, so it's not a Google Doc. I tried to copy and paste it into a Google Doc, and it just messes everything up. So Microsoft and Google don't play nicely together, and we'll just have to deal with it this way. So this is just reference anyhow, and you'll be able to use this on the quote-unquote quiz. That's not a quiz, the activity at the end. So everybody knows, I hope, that lab burners are the fun part of chemistry, but we have to be safe about it. So the classic name for a laboratory burner is the Bunsen burner. Of course, you guys know that. Robert Bunsen was a very, very, very good chemist back in the day, in the 1800s, and he's credited with inventing or designing this style of burner. It was probably his lab technician, but that's okay. He was the head of the lab, so he gets to get his name on it. It's not the most important thing he did. He discovered elements. He did lots of spectroscopy. He figured out a whole bunch of stuff. Way more important than this burner, but burners are the memorable part of chemistry, so his name is stuck to it. Whether that makes him happy or not, well, it doesn't really matter because he's not around anymore. But sorry, Bob. All right, so let's go through a few bits of information about how a burner works. I think I've already talked to you guys about hydrocarbon. Get this all over here. I forgot to erase from last period. Just trying to center it. I don't know how well you guys can see it at home, but hopefully you can see some of it. Can you guys see my board? Okay, cool. They're telling me here in the classes that it works. So, the burners are using natural gas, and that's kind of a misnomer because natural gas can mean a lot of things. Gas comes out of the ground. Most people, when they say natural gas, they're talking about CH4, and we've seen that molecule. You've done the diagram for this molecule. CH4 is properly called methane. Simplest hydrocarbon, one carbon with hydrogens filling each of the 4 valence electrons on the carbon. C3H8 is probably the gas that you have if you have gas at your house. Anybody have gas at their house? Yep. Okay, 2 out of 3 for heating or cooking. Yeah. Okay. So that, you know, of course, is propane, and we don't call propane natural gas, even though it's part of this. Propane is a bigger molecule. It has 3 carbons and 8 hydrogens instead of 1 carbon and 4. And it, because it's a bigger molecule, it takes less pressure, even though there's still a lot of pressure, it takes less pressure to liquefy it. And if you can liquefy, that doesn't look like must be Friday afternoon. If you can liquefy a gas, you can compress it and smash the molecules together to turn it into a liquid, and it's easier to transport. So those of us that live in the foothills and in any rural area, actually, it's not cost effective for the power companies to lay pipe out to just a few people over a big distance. And also in this area, going through all the granite we got around here, anybody's tried to dig a hole around here knows about the rocks. So if you want to have gas at your house for heating, cooking, you're going to have propane. In the valley, they're going to have natural gas. It's just the smaller hydrocarbon. So there's actually another hydrocarbon that's usually mixed in, at least partially, with methane, and that is called ethane. And actually, this can be made into ethanoic acid, which is another name for acetic acid, which is vinegar, which is really weird. Some companies use the natural way to make vinegar, like Heinz. Others use natural gas to make it. It's really bizarre. Anyhow, just a little side thing that popped into my random brain. I apologize. So these two are so small that it's really, really, really hard to compress them to make them liquids. Propane's a little bit more, little easier to do. And then some of you may have heard of the fourth one in the line, and that's butane. So lighters that you have use butane, and butane very quickly turns into a gas. It's liquefied, but it very quickly will go to a gas. Propane will go straight to a gas as soon as the pressure is taken off of it. Hey, a present? Oh.
I have a handwritten card and a cookie from leadership for you.
Thank you, leadership. Thank you. Thank you, guys. Okay. So these four molecules are the smallest hydrocarbons, and we're going to learn more about them later. But the reason why I'm talking about this is because on your paper or on the document, it talks about methane as being the natural gas. For us, it's going to be propane, and that's fine. It's not a big deal. The process is the same. All of these gases combine with oxygen to produce carbon dioxide and water if, that's a big if, you have complete perfect combustion. Most of the time there's not perfect combustion, and that's what Bunsen's burner did, is create a device that more completely combusted the gas. And so because he figured out a way to get the oxygen in an efficient way and make sure there's plenty of oxygen coming in, the flame gets hotter. That's actually one of the questions on the little quiz document. Okay, so it mixes the air with the gas before combustion, and that makes sure that you get complete combustion, less likely to get stuff like carbon monoxide, which tragically has killed a bunch of people recently in Texas, like I mentioned last week. All right, so very, very basic, simple device, not a lot to it. There's a barrel up at the top, and I'm just going to take this off. You would never take off the barrel in the lab situation, but there's a little tiny opening in the base of it, and that is where the gas comes from the nozzle in through the tubing into your burner. I'll put this back on. And in addition, there's these other names here. So the mouth of the tube, pretty obvious, the opening, the barrel, and then down at the bottom, there are holes in the barrel. So those little vent holes are where the oxygen comes in. So the gas is shooting in, the oxygen gets drawn with it, and then you ignite it after they're already mixed up. Okay, this little collar on the base is to be closed when you're first lighting your burners. If you have this style, you might have a different style at your lab station. I'll show you the other one in just a second. But we close the collar, which seems counterintuitive, but that's just to initially light it, and then we adjust it after that. All right, so for safety, you want to make sure your lab area is always on. And we'll either light with matches or a striker. Strikers, anybody do welding? You guys, anybody done any welding? Yeah. So people who weld typically use strikers. I don't have, oh, it's a spark. So usually I can't get it to spark, but with one hand. There's a little flint that is replaceable on the strikers. So these are nice, there's not a lot of waste. And that just screws onto the end. If I can do it, there we go. And the striker makes sparks, and those sparks then of course can ignite the gas and air mixture coming out of your burner. And so they're very, very handy, very easy to do. Matches, of course, will work as well. This talks about using a lighter. It's ridiculous to use a lighter to light a burner, I think, personally. But it leaves less waste around, I guess. I don't know. So wooden matches are pretty straightforward, easy to do. We also have the paper book matches that a lot of people are scared of, which is good. Smokey the Bear did his job with you guys really well. People don't like matches and get really scared of them. They're not going to hurt you, I promise. Don't ever light a match this way, okay, by bending the book backwards. That's not the proper way to do it, and you can send pieces of phosphorus flying onto your lab partner. So just the lighting process is maybe, this is almost at the end, maybe a little bit difficult. They're not going to hurt you, I promise. Okay, so that, our lab benches are ceramic, and they're not like white porcelain ceramic, but they are fireproof. Okay, you can see where they've been heated over the decades that they've been in here. This building was built in '64, I think Mr. Lemon said. So lots and lots of chemistry has been done on those lab benches, and they're perfectly fine. It says to extinguish the matches with water. That's not necessary. You just set them on the counter on top of that. All right, before I forget, I'm going to talk about the Tyrrell burner really quickly. Lots of people call these Bunsen burners. They are not Bunsen burners. Bunsen burners are the super simple one I just showed you. Tyrrell burners are modified Bunsen burners, I guess you could say. They also have a barrel, and that barrel can come off. But this time the vents aren't covered. Okay, so the way that you close the barrel vents on a Tyrrell burner is you twist it down. And you can twist them all the way closed so there's no oxygen getting in at all. You don't want to do that. Okay, so I'm just going to back it up. Sorry. You like to see just a little bit of a gap at least at the bottom, and then you can adjust it as necessary from there. What's nice about these is you can adjust the gas to different places. And the Bunsen burner, the true Bunsen burner, there's only the gas nozzle that adjusts the gas. On the Tyrrell burner, they have a little knob underneath the base that is actually a pin that seats into the hole. I'm trying to get out, it takes forever, sorry. Okay, so this little needle valve, so this little thing right here seats into the opening where the gas could go into the barrel, and you can close it all the way down. Some people recommend, I saw a bunch of videos, trying to find one that was decent, and I don't like any of the videos I saw. So once you get it completely righty-tighty, so looking at the base, turning to the right, once you close it completely, there's no gas going to get through. Some people say to close that off before you turn it out. I think that's a bad idea, because then the gas can still be on at the nozzle. So my recommendation to light these is to close it, but open it up a half to a full turn. Okay, and you'll need to be able to hear the gas coming out, and I'll show you that in a second. And then you can adjust the air by twisting the barrel up or down, and you can also adjust the gas again at the valve handle. All right, let's get to it. So basic safety, always, 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 anytime there's flame, hair's tied back loose clothing, secured, um, dangly things should not be around your neck, like keys and stuff. So I don't have them on, so good. Okay, and then the rubber tubing, you need to inspect it and make sure it's not cracked. And actually, this one's getting a little iffy, but I don't see any openings, so that's good. Make sure that the end isn't split. Okay. This hosing is getting pretty short. Our gas jets are up on the risers up high, and so this one actually, I don't know if it is the last station. Oh, I know what I meant. Sure. I have, so those of you that are in the room, I have rubber stoppers put on all the gas jets, black things, because if you look at your lab station and you're fighting like this, bring your head up on one of those, it hurts like holy heck. Okay? Ask me how I know. So I put these little stoppers on there. The stoppers are like little bumpers to keep you from scraping your head on the gas jets because they're up high on the risers. And if you're back there, it hurts. It hurts. So make sure when you put the hose on that you shove it on at least 3, maybe 4 or 5 if you can get it, ribs on the jets. So okay, thank you so much. So there's two styles of nozzles. There's 2 different nozzles at each lab station. One is for air, which we don't have any access to anymore. Back in the old days, they had air lines running in, but when they did the industrial arts building years and years ago, they cut the lines, and it's not really that important. But the little blue topped handles are the ones that the propane comes out of. And there's a nozzle, and again, it has ribs on it. And you want to make sure that you get at least 3 ribs up with your gas burner hose. A couple other things about the gas jets. Each one of these valves is a different tension. They're old. But anytime the handle, the little paddle thing, is perpendicular to the nozzle, it's off. Okay? And it doesn't matter if you go to the right or the left. As long as you're away from the nozzle, it's off. The only time it's on is when it's in line with the nozzle itself. That's when the gas is going to come off. However, there's a little gradient. You pretty much never want to have it full on. I don't think there's any of the valves that need it totally on. You probably want it at 45 or 30 degrees. Okay, bring the paddle down to there, and you'll be able to hear it, and then you can adjust it if you need to. Again, the Bunsen burner can only be adjusted at the handle, at the valve. The Tyrrell burner can be adjusted underneath as well. All right, so a couple things. Matches. If you use a match, you want to light the match first. That's a big deal. Probably you can figure out why. Why would you want to light your match before you turn on the gas? Right. So if you're bumbling around trying to get your match lit and your gas is just into the room, when you finally get it lit, it might not be a good thing. So what we do is we say, if you're lighting with a match, first light the match. Okay, then I guess just put a second, then turn on the gas. Okay, so and then the third thing with using a match is you bring it alongside the barrel. Okay? Side of barrel, not over the top when you're lighting. So what I mean by that, let's see if we got gas still. I have an automatic shut up in this room. Okay. All right, so light the match, maybe, and hold it off to the side. If you hold it over the top, it can blow out. So The matches. Oh yeah. Okay, I gotta go turn the gas back on. This is normally lunchtime. A little safety valve they have. Sorry about that. So light your match. And then hold it off to the side. Keep your face coming over the front of it, especially with the mouse on. And then you get something that looks like that. And you guys see it? Can you guys pin that? I don't. Okay, let's see if I can get that pinned. Oh, it's not going to work. Okay, let's see if I can get it. All right, I can do this. I promise I can do this. A little bit up. Better? Awesome. Oh, yeah. They're coming for me. They've heard I was lighting stuff on fire. All right. So this is a really bad colored flame. You don't want your burner flame to look like this. That yellow up there means incomplete combustion. How do you fix that? Well, you add. That's the beauty of the bunsen. Yes. So that roar of the burner is good. Down low. And adjust the gas. Up or down. You probably don't need it on the glass. The top cone, from my perspective, looks a little bit violet. It's big. But the hottest part of the flame is right here in this turquoise part, right at the tip of that turquoise flame. Okay? Is the rest of it hot enough to hurt you? Yes. Can it light stuff on fire? Heck yeah. However, if you're really trying to heat something up rapidly, you want to put it at this part. You see how the nose light. And so that's the hottest part of the flame. There's also a dark region in it. It's actually hollow. The flame is actually around the rim. And the center part of it actually, I haven't had any luck with it today, but usually I have put a match in the center and it will burn light. Yeah, but it's all the outside part that will charcoal you. Sure! You know, it's like you do at Thanksgiving, right? Don't do that in here. Okay, playing on the candles. So that's how you adjust the flame. You turn the collar to change oxygen. Bad flame. Good flame. So it's like all flame that yes, that yellow that you're seeing, that's carbon particles that aren't combining with oxygen. So there's not sufficient oxygen for the volume of fuel, and you need to adjust it to get that bright blue turquoise inner flame. And you can hear it, hopefully. Sorry, those of you at home, if you can't hear it. Okay, so that's the Bunsen burner. I'm going to use the striker to light the Tyrrell burner. So it's a turquoise inner cone. So there's a purpley, faint, bigger cone, and then in the middle there's a really intense turquoise cone. Right at the top of that is the hottest spot. All right, so the Tyrrell burner, same process. Make sure the hose goes on completely. This one, you know, close it down a bit, close it down a bit. And I'm going to use the striker this time. I'm going to not touch the end like I did last year. It can. It will for sure be hot at the top. It shouldn't get super hot at the bottom, but a couple of these I know. So you want to be cautious, but they do have a bigger surface area and they're sitting on the cold counter, so usually put that well. I can't hear that, so I'm not opening it up. There we go. I can hear that. I need a spark over time. You sparkle the top. Again, bad flame because it's yellow, not enough oxygen. Two things to do. You can dial up the barrel. That gives more oxygen coming to that bit of fuel. And another thing you can do is you can close it down if you don't want it that high. So I can close it, and that makes a hotter flame. Okay, so I'm getting the proper air to fuel mixture. That's a perfectly fine flame. So right here at this heat of the chips. And then to turn them off again, either direction with the paddle, doesn't matter. And then let it cool for a bit. Or on this hand, just put it back in your drawer when you're all done. Okay, so that is our burner. Okay, thank you. Good. It's the volume. I think it's just Bernoulli's principles kind of stuff. It's airflow. It's just the volume of it coming through that small tubing, kind of like blowing through a brass instrument. It's rushing through and it's convection, and so it's sucking in the air from the bottom as it's going up and out. All right. Any questions? Any other questions?